So we're going to talk about angles and angle notation. And so what is an angle? An angle is formed when you have two rays. So notice A to M is a ray. It's a ray because it starts at a point, it goes off in one direction forever. And AX is a ray because it starts at A and goes this way forever. So this point at which the two rays intersect, we call that the vertex. Now the two rays, so the AM and the AX, we just call that the sides of the angle. So you have the side, the vertex. And when naming angles, it is typical to use one or three letters. Sometimes you cannot use just one letter. When using three letters, so like if I'm calling this angle by MAX, it's important that the vertex must be the letter in the middle. So when you're naming your angles, the vertex must be in the middle. So here's an example. Name an angle using one letter. I could just call this angle A. Okay, angle A, we're assuming is this angle right here. Now, I could name using three different angles. So three different angles. I could call this so if I want to name three different angles, I could call this angle MAX. The max angle, right? I could call this angle XAM. And notice A is always in the middle because it's the vertex. Or I could just call this angle A because there's no other angles on the screen. And now we're talking about angle IRC. So sometimes I like to highlight what they're talking about. So angle IRC, so if I go to the vertex R, go to C. And so I can name that in two other ways. I can name it, instead of IRC, I can name it. So IRC could also be called CRI, and it could also be called angle 1. So you can name angles multiple ways. Now we talked about a plane. A plane goes infinitely in every direction, and we drew an angle. And an angle breaks up a plane into three regions. So we have the outside of the angle, we call that the exterior. We have the inside of the angle, we call that the interior of the angle. And then you also have the points on the angle. So what I want you guys to do is look at this drawing and name points on the interior, and then also name points on the actual angle. Okay, so you can pause this video, put down what points are on the interior and what points are on the actual angle. So points on the interior of FAB would be T, S, and R. T, S, R. Have T, S, R, and then the fourth one, I guess, is page number 1. And then name the points on the angle would be F, A, B, and Y. And if they ask for exterior angles, I would say N is on the outside, M is on the outside. Alright, so more examples. We're going to name the angle in 4 ways. So as long as A is the vertex and we use 3 letters, we're good. So I can name this angle BAT. BAT. I could name this angle TAB. Angle tab. I could also name it by the angle number inside, which is angle 2. Or because there's no other angles on the paper, I can name it angle A. Now, what are points on the interior? K. And let's see, this goes forever that way, so B would be on the interior. Exterior, outside, would be point R. And on, looks like I and C are on the angle. And then we're not going to cover the part with the protractor. You should remember how to do that from middle school. So we'll go ahead and go to the next page. So let's talk first about the angle addition postulate. And I'm going to draw a diagram for this. So for any angle ABC, so I'm going to draw ABC. So B has to be the vertex. And then I'll have angle A go this way. And C go this way. So for any angle ABC, and I just drew a random angle, if D is in the interior of ABC, so let me just put D anywhere in the interior, then if I were to make this into angles, we know that the measure of ABD, and that's what M in front of angle means, measure of angle. So if I take this part, that's ABD, and I add on DBC, then that is the whole thing. So if I take this angle plus this angle, I get the whole measure of the angle ABC. So the two parts equal the whole angle. That's what we call the angle addition postulate. It's actually pretty simple. The orange plus the pink equals the whole thing. Alright, so we're going to use this angle addition postulate, and we'll also be using this in proofs. So you can't just, if you're showing the algebra, you don't have to prove, but a lot of times we'll be doing proofs later in class, and you may have to reference the angle addition postulate. Let's do an example. Suppose measure of angle KNL is 110. So K to N to L is 110 degrees. And the measure of LNM is 25 degrees. What would you do to find the measure of KNM? And KNM is the whole thing. Well, we're going to use the angle addition postulate that says if you have a point in the interior and that makes two angles, then both of those add up to the whole thing. So by the angle addition postulate, I will just take 110 plus 25. And I should probably put the measure of angle KNM equals the measure of angle KNL plus measure of angle LNM. And that is by the angle addition postulate. So K and L, and I'll color code this, that would be the blue. LNM is the green. So really all we need to do is take blue plus green, be 110 plus 25, which is 135. So I would say measure of angle KNM equals 135 degrees. Now I always like to look at it and see if it makes sense. This angle is what we call obtuse, so it should be bigger than 90. I got an answer that was bigger than 90, and this looks like 135 degrees to me, approximately. Okay, so how did I do this? I did this by the angle addition postulate. So what I want you to do now is I want you to try the second example. And if you're watching at home, you can hit pause and then check your answer. So suppose the measure of M in K is 155. So M in K is 155. That'd be the whole thing. And the measure of angle LNM is 30. So I start at L, go to N, go to M, is 30. What would you do to find the measure of LNK? Well, I would use the angle addition postulate that says the measure of K and M is equal to the measure of K and L and I'll call it the same they did. They call it L and K, same thing. Plus the measure of L and M. So the whole thing is equal to the orange plus the green. So I know the measure of K and M is 155. I'll write it like this. Make it even easier to see. 155. And that equals, we're trying to find L and K, so I'll just leave that measure of angle L and K. And then we know that L and M, this green part, is 30. Trying to solve for L and K, I would just take away 30 degrees from both sides. And I get the measure of angle L and K. 155 minus 30 would be 125. 125 degrees. So let's check our answer. Is 125 degrees plus 30 155? Yes. Okay, so we were able to solve this by the angle addition postulate. Now there's another type of angle so a ray that divides an angle. So if you had a ray and it divided this angle into two equal angles, two angles of equal size, or I guess I should say degree. I'm going to say degree. We call that an angle bisector. So if you have a ray, and this is not an example because this is clearly smaller than this part, But if D was a little bit over, then we would say D, the angle, or the ray BD, is an angle bisector.